This screencast is for packet pages 1 and 2. What you're going to need to do is you're going to need to click on this here to make a copy of your assignment. And what that is going to do is going to bring up this where you're going to be inserting the pages from the packet, pages 1 and 2. You're going to insert these pictures into here and you're going to turn this document in, and that's how you're going to turn in to get credit. What I have here is I have some slideshows that will show us like what we can use to do this. This is going to be a tool for us. I have right here how to turn in this assignment, so you can watch this video on how to turn in the assignment. I also have this slideshow down here about the velocity equation. I have how we're going to be graded on for this assignment, as well as some graphs that you're not going to have to do by hand or draw in, but we're going to use these graphs already pre-made. Further, I want us to focus today on this d, which is going to be for the distance or the displacement, which is going to equal to velocity times time. So we're going to use that as well as this graph here in order to do this first page. So as I bring us here to this first page, this is that first graph. So you don't have to graph this by hand. It's already done for us. So I'm just going to even do this right here. You don't have to cross it out if you don't want to. But what I'm making it clear is that we're not plotting the position versus time for this skater. We see how the skater's displacement, we see where they are over time. And so we can then explain how we're going to use that graph to determine how far this person was from the origin at time equal to 6 seconds. So we're going to use this graph that we have here where it starts at this point 10, and over the entire time of 10 seconds it goes up to 30. So over the entire time it went up about 20 meters. But we're talking here at the 6 second where it looks like it's about 22, 24. I'm going to say 22 meters. So from that, now we know that from the graph that they started at a position, so this initial position, this x0, this is where they start. They start at 10 meters and went to x, this is going to be for the distance. Now this x sub 0 is its initial position. That's where it starts at time equal to 0. That's why there's a little 0 down there. And then its final position was at that 22 meters, so 22 meters. And we can then say, well, how far did they go? Well, it's going to be 22 minus this 10. And so they traveled then 12 meters. That's how far they're displaced. So they went from 10 to 22 and they traveled 12 meters. And now we can write a mathematical expression for the skater as well. So just like how I told us to look at that, this d for displacement or distance is going to equal to velocity times time. Another way to write this is also going to be that x is going to be the same thing for displacement or distance. It's also going to equal to this velocity times time. What I'm going to write in is I'm going to write in another term here, plus x naught or plus d naught. It depends on how you want to look at this distance or displacement. It's talking about the same thing. So this displacement, x, is going to equal to velocity times time plus this initial position. So we can write a mathematical expression for the skater, but we got to get how fast this person is going. So we can get to the velocity, just like in that slide where you can look for the velocity equation. I'm just going to choose 2 points where I'm going to get the change in position over change in time. And so I'm going to choose 2 points where I'm going to go starting from the 30 minus 0 divided by 10 minus 0. So I'm just choosing 2 points on that line, so I'm just choosing the beginning and the end point. And what we're getting here then for this velocity is going to be 30 over 10, or 3 meters per second. So the expression then for this skater is going to be specific for this skater. This x is going to equal to 3 meters per second times time plus an initial position, where we know this initial position of 10 meters. So x is going to equal to 3 meters per second times time plus that initial position of 10 meters. So this is going to be a mathematical expression or mathematical model for how this skater is moving. And we can know exactly where they are based on the time. So if we know the time, then we know exactly where they are. And lastly, was the speed constant? Yes, the speed was constant. And we know that because the line was linear. The graph was linear. So I want you to take this and also apply it to our page 2, which is on the other side. It's going to be following the same format. So follow that format to do page 2. Use the graph that you have on there as well.